Hello students, welcome back once again to my maths class. In this session, we are going to learn a new chapter in class 10, that is chapter 10, mensuration. Right, mensuration. This is a new word, you have heard it, but we have done this in our previous classes, that is in 8th and 9th, but with a different name, that is surface areas and volumes. So this mensuration is nothing but this is a branch of mathematics involving the surface areas and volumes of solid objects. Now let me recall those concepts which you have learnt in your 8th and 9th class. Now here when we are talking about the surface areas, so mensuration is nothing but the surface areas and volumes of solid objects. Surface areas and volumes. Okay. Now when I am telling about the surface areas and volumes, now we know how to differentiate between the surface areas and the volumes which you have learned previously. That is the surface area. For example, if I say I want the quantity of paint required to whitewash a room, then we will find the surface area, not the volume, isn't it? Similarly, if I want to fill the same room with the grains of rice, then I need the volume, not the surface area. So we know how to differentiate between the surface areas and the volumes. And also let me recall that we have studied few solid objects like cube, cuboid, their surface areas. Now let me tell you the cube, cuboid in the 9th class, right? The difference between a cube and a cuboid, their surface areas and the volumes also we have studied. Now let me show you an example of a cube, right? This is an example of a cube. Now this is the dice which you play, okay? So this is in the shape of a cube because it is having all the faces, all the lateral faces as squares, right? All the faces here in the dice are squares. It is having 6 faces. Now we have learned the surface area and also the volume in the previous sessions. Now another example can you give me for the cube? That which you play, that is the Rubik's cube which you play in your lower classes, that is the Rubik's cube is also an example of a cube. Now how do you differentiate between a cube and a cuboid? Now here cuboid, this is the duster which you use to erase, okay? The duster is in the shape of a cuboid. Here clearly when you see the cube is having all the lateral faces as squares, whereas the duster, it is having the lateral faces as the rectangles. All the 6 faces are the rectangles here, okay? Now this is a cuboid. An example of a cuboid you can give as most of your classrooms are in the shape of a cuboid. Your textbook, the textbook is also in the shape of a cuboid. Also I'll show you one example. Now this is a packing box, right? This is in the shape of a cuboid. This is also not a square but a rectangle. See here the breadth is a little bit less than the length. So this is in the shape of a cuboid. Packing boxes, your classroom, your textbook is also in the shape of a cuboid. All this we have learned in our previous classes. Now in this session we are going to learn about the 2 solid objects, that is cylinder and the cone, right? We will learn today cylinder and cone. These are the solid objects and we will try to understand the concept of cylinder and cone, their surface areas and the volumes in this session. Now for example, I'll give you example of a cylinder, right? Now this is a box, like this is a solid figure, not a box. Here this is a cardboard box which is used to place the shuttlecocks, okay? So this is in the shape of a cylinder. You can clearly see there are the circular bases and the curved surface. So this is an example of a cylinder. The shuttlecocks which are placed in this, an example of a cylinder. And a cone, example of a cone is a joker's cap, or else if a heap of grain, when they're placed on floor, the heap of the grain that is in the shape of a cone. Now first let me discuss this cylinder first. Okay, here we will discuss cylinder. Right. Now if I take a paper which is in the shape of a rectangle. Now the rectangle means length and breadth, right? This is the length, this is the breadth. Now I'll show you one paper. I've cut one paper which is in the shape of a rectangle. So this is a paper in the shape of a rectangle. Now here, now what is a cylinder? Now if I join this breadth with the other breadth, if I roll it and join the two breadths here, this forms a cylinder, right? Now this is the shape of a cylinder. See here students, this is the shape of a cylinder clearly. Now if I open it up, this is a rectangle. Now the shape of a cylinder, I have shown you the shuttle, the box placed for the shuttlecocks. Now this is a cylinder. Although this is a hollow cylinder because it is not having any bases here, but this is the shape of a cylinder, a right circular cylinder. Now how do we get the curved surface of a cylinder? Now let me tell you the curved surface, right? The surface areas we will find, the surface areas means one is curved surface area and the total surface area. The curved surface area of a cylinder, right? We will find the curved surface area. So in short we called it as a CSA, right? Now see, if I tell the curved surface area here, if you see, now the curved surface area of a cylinder. Now you know what is a cylinder, a solid object. Now I have shown you the example of a cylinder like this, right? Now I want the curved surface area of the cylinder. That means I want, if I open it up, I want actually the area of the rectangle, right? If I take it a little bit less here, so I want the area of this rectangle. This rectangle itself is the, if you see clearly, this is the curved surface area. Now the curved surface area here is the rectangle area. So L into B here, right? Now L, now here L, if you see L and B, now what are these L and B? I'll show you here. This is the B part, this is the L part, right? Now if I am turning this and folding it here like this, so this becomes, the L is been rolled to round, right? So this L is the perimeter here, the perimeter or the called as the circumference of a circle. Now see, this has been rolled and formed in the form of like this, right? This is a cylinder. Now this L is this complete thing, right? So this is nothing but the circumference of a circle. The circumference of a circle, we know that it is 2 pi r into. Now what is that B? Now here B is this part. That B becomes, when you roll it, it becomes the height. Just the height of the cylinder. So instead of B, we will write the H, right? Now this forms the CSA. 2 pi r H is the curved surface area of the cylinder. Now this B here, it becomes the height, right? And you know, if it is circle, this is the radius, right? And this is the circumference, 2 pi r. Here this is the H. So 2 pi r H is the curved surface area of a cylinder. Now let us know what is the total surface area, right? I'll tell you the total surface area. Now the total surface area, of cylinder, right? Now how do we find this? Now we will see the example one. Now what I have showed you, the box to place the shuttlecocks. This is the box, a cardboard box. Okay. Now here I am telling this curved surface area means just the surface area of this part. When I am telling the total surface area means the curved surface area plus the area of the bases, both the bases, this side and this side. Okay. So area of CSA plus the area of the bases. Two bases it is having. So that gives us a total surface area. Now here. So what is it? It is curved surface area. I have written in short, curved surface area plus 2 area of base. Now here the base is circles, right? 2 area of the base. Now what we found out, the curved surface area as 2 pi RH, well, and plus 2 into area of base. Base is the circle. So what is the area of a circle? Pi r square. So 2 pi r square. So in these two, when you see, there's a common thing, that is 2 pi r. I've taken common. The remaining is h and plus r. So this is called as the total surface area of the cylinder. So in short, we call it as TSA, right? TSA of right circular cylinder is 2 pi r h plus r. And don't by heart the formulae, but you need to understand the concept and you can easily get it. Okay. Now, how do we find the total surface area? The curved surface area plus the area of the bases, two bases, top and the bottom. So the bases are the circles, so I've added the circle area. Now this is the total surface area. Now we will find the volume of a right circular cylinder. Now actually, to find the volume, for volume of any solid object, suppose if I say this one, the cylinder, we will find the area of the base into height, that gives the volume. So if I want to fill this cylinder with some sand, okay, that sand, the quantity of sand it contains is the volume, isn't it? So how do we get the area of the base into the height gives us the volume? Okay, so we will write it, area of the base into the height. Right. Now the area of the base, here the base is circle, so it is pi r square. The base is circle, so pi r square is the area into h. So this comes to pi r square h. Right. This is the volume of the right circular cylinder. Now pause the video and quickly note it down. Let's see. Now we will find out the surface areas of a cone and the volume of the cone. Now let me draw for you the cone here. See here, I'll draw for you here. This is the shape of a cone. Now the example of a cone is a joker's cap, I told you, and also the ice cream cones which you eat. The ice cream cone is also in the shape of a cone. Also, when you drop a heap of grains, that is in the shape of a cone. Here, a joker's cap. If I suppose this is a joker's cap, this is the apex and that is also called as the vertex, and the base is a circular one. Now this is the, when it is circle, it is the radius, this is the height. There are two heights here for a cone. If you see this is the vertical height, okay, so that I called it as h, and there is another one which is sliding over here. This is the slant height, so this let me call it as a L, slant height L. So in cone we have two heights, a vertical height and a slant height. This is the normal height, that is the vertical height h, and r is the radius. Right. Now this part is a circle. So now a circle, right? This is a circle. Now that part I've written it here. The area of the base here is a circle. The area is equal to pi r square. Okay, this is a circle. Now I want to show you how you get a cone. Now let me take a circle. Now if I take a sector, this is the center O. Okay, these are the radius, right? From the center to the any end of the circle, this is the radius. Now this part is the sector. Okay, now I'll show it using a paper. I've cut one sector. Okay, see here, this is a sector, right? Now this is the center. Now it is a part. Sector is nothing but a part of a circle cut from the center. Now if the sector, if these two are the radii. Now I will join both the radii here. See here, I am joining both the radii here. Simply here. See, if you see this is forming a cone, right? Now this sector part, I have joined these two radii and formed a cone. This is in the shape of a cone, rightly. Now if you open it, the radii here, this is a sector. This is a center which I am keeping it with the thumb. This is a sector. Okay. Now, so you have understood the cone here. Now if I say this is A, this is B. Now the sector here is OAB. Let me suppose the sector. Now the sector also you have studied in your previous classes. Now also you have studied in the tangents and secants chapter the sector, area of the sector. Here the sector area is equal to the curved surface area of the cone. This is equal to CSA of cone. I have showed it lively here. This is the area of the sector. This is the area, this complete pink part. This area will, if I fold this to the radii here, this becomes the cone. So the curved surface area is this part, isn't it? The area of the sector is nothing but the curved surface area of the cone. Now if I find the area of the sector, we will get the curved surface area of the cone. Now here if you see these are the r's, and when I fold it out, I'll show you again. When I have folded this, the radii has become the vertical height. This vertical height here, it has become this radii of the circle has become the slant height here. This is the slant height which is sliding over here. This L is nothing but the R of a circle, right? Here, that concept you learn here. This is nothing but the R. Here I can remove this L here. This R is nothing but for me L as far as sector is concerned. And also if you see the length of the arc here, this is arc AB, okay, a minor arc here. This length of the arc AB, if I fold it, it becomes the circumference of the circle here. Just if I fold it here, now this is the cone. I folded it and you get the circumference of the circle. This arc has become, after folding it, it clearly becomes the circumference of the circle. Okay, so this, how can I tell the circumference of the circle is 2 pi r, isn't it? Now this is 2 pi r. That means I'll write it here. The length of the arc, AB, this is the arc AB, is equal to 2 pi r here, because that has become the circumference of the cone. Now we know the length of the arc, the formula of the length of the arc. If this is the theta angle here, angle of the sector, the length of the arc is given by theta by 360 into 2 pi r. Okay, but this r is nothing but the L. When it is folded, that r has become the slant height. Okay, so instead of r, I'll write L here, because the length of the arc here is theta by 360 into 2 pi L. This is equal to 2 pi r. We got this. Okay, till here you understood. Now let me cancel the common terms here. 2 here, pi value and pi value. This comes to theta by 360 into L is equal to R. Now this we will keep it aside. So the R value I have got, see the R value I have got it as theta by 360 into L. This you keep it aside. Okay. Now here, now from this what we want, the CSA of the, now the area of the sector is equal to CSA of the cone. We didn't find the area, we found only the length of the arc. That length of the arc, from that we have found the R here. Now if you come to this part here, if I see, now I know the area of the sector. Here, area, okay, area, sector of area, okay, area of sector is equal to, what is the area of the sector here? That is theta by 360 into pi r square. This is the formula for the area of this sector. Now here in this there are r square, 2 r's, and if you see here, we can clearly say this 1 r is here, isn't it? Now here theta by 360 into pi r square is the area of this sector. Now here r, here the sector R is the L if you fold the into form of a cone. Now this is the CSA, isn't it? Curved surface area. See, the area is equal to curved surface area of a cone. So area. Now here I'll write this as theta by 360 into pi L square here. This is CSA, okay? L square, because here the R is L. The radius of the circle has become the slant height of the cone. Now in this there are 2 L's. I will replace it like this, pi L into theta by 360, right, into one more L, like this. I have split the L into 2 parts, pi L into theta by 360 into, so this is one CSA. Now here, now this L value, this value here, pi L, and in place of this we will substitute R, okay, this is R, simply, okay. So therefore the curved surface area of a cone is simply pi r L, where L is the slant height of the cone, R is the radius of the, so therefore the curved surface area of the cone is pi r L. Now I'll explain you again, I'll repeat it, don't get confused, very simple. Now this area of this sector, when I folded the 2 radii, it becomes a cone. Now here the radius has become the slant height of the cone, and this length of the arc will become the circumference of the cone, the base of the cone, okay. So that is 2 pi r. Now the area here, area of the sector is the CSA, that is the curved surface area of the cone. Now I'll find the area of the sector. If I find the area of the sector, that means I'm finding the CSA of a cone. Now I'll start with the length of the arc, just the length here AB. Length of the arc is 2 pi r, and the length of the arc, formula of the length of the arc is theta by 360 into pi 2 pi r, where here r is the L. So I've replaced r with L, and both sides if you see 2 pi is common, I've cancelled the 2 pi. Now I've got an equation in r where r is equal to theta by 360 into L. I've kept it aside. Now we will find the area of a sector, that is theta by 360 into pi r square. This area of the sector is nothing but the CSA of a cone, right? This is CSA of cone. Now in this area formula, r is nothing but the L. I'm replacing r square as L square. Now this I'll write one L here, pi L, and the other L I'll join it with this. So I've just split it, that's all. And this part is nothing but, I'll substitute this part as R. This is completely R. So in place of theta by 360 into L, I've written R. So the CSA of cone is pi r L simply. Now here, please pause the video and note it down. We'll see the TSA of the cone. Now we know the CSA, we got the CSA as the pi r L. Now we will find the total surface area. If you see the cone here, see the cone, Now here the total surface area is the surface area CSA plus the area of the base here, the area of the base. Base is the circle. So adding them we get the TSA, right? The total surface area of cone is equal to the curved surface area plus the area of the base. Area of base. Here the base is the circle. So, now we found out the CSA. CSA is nothing but pi RL plus the area of the base. Base here, the base of the cone is a circle. So the area is pi r square. So pi r square. Now here, now take the common things. Pi r are common in both. So pi r L plus R. The leftover is L plus R. This is the TSA of a cone. Now we will find the volume of the cone. If you see the ice cream cone, how much ice cream it has been filled up, that is the volume, isn't it? Now the volume of a cone, to find the volume of a cone. Okay. Now, for this I'll tell you an example, and we will take two. Now we'll compare it with the cylinder here. This is the cylinder and the cone. Okay. Right. Now they are having the same vertical height. With the same vertical height I've taken the cylinder and with the same radii. Okay. The h both are the same. Okay. The vertical height h and the height of the cone. If I take both the similar cone and a cylinder, we know that the volume of cylinder, what is the volume of cylinder? We just found out. Okay, this is pi r square h. Now here I'll tell, if I fill this cone with some sand, and if I start filling this cone with sand, and if I pour it into the cylinder, it is seen that we can get 3 times of the cylinder. That means 3 times I have to fill this cone to fill the complete cylinder. That means the volume here will become 1/3 of pi r square h. Okay, that means if I take a cone and a cylinder of same height and same radii, if I take the cone first and if I fill it with sand or grains of rice, then 3 times I have to take the volume of that and to fill the complete cylinder. Now you can check it practically also. If you fill with the grain 3 times, if you fill in and pour it into the cylinder, it completes the volume of the cylinder. So that means this volume of the cylinder is 1/3 the volume of the cone is 1/3 the volume of cylinder. Although we know the volume of the cylinder is pi r square h, therefore the volume of the cone is pi r square, 1/3 pi r square. So the volume of cone 1/3 pi r square h. Right. Right. So today we have known the cylinder as well as the cone, the solid objects, their surface areas, the total surface area, the curved surface area and the volumes. This concept you have learned it. Now in the next session we will be doing the sums regarding the exercise 10.1 regarding the cone and the cylinder. And do learn the concept well, children, and tomorrow we will see with the exercise problems. Thank you all.